Next session, implication and anupalabdhi, non-apprehension. Let's explore arthapathy or implication and anupalabdhi, non-apprehension in detail. So implication and non-apprehension. Implication in detail, often referred to as implication, as arthapathy, often referred to as an implication, I'm not sure about the pronunciation, is a significant pramana or means of knowledge in Indian philosophy, particularly in Nyaya. It involves the postulation or assumption of something to explain observed facts or events that cannot be explained through direct perception, inference, or testimony. Process of this observation of an unexplained fact. The individual observes a fact or event that cannot be adequately explained based on existing knowledge or means of knowledge. Then postulation of an unseen cause. To account for the unexplained fact, the individual postulates the existence of an unseen cause or condition. Then inference of knowledge. The individual infers knowledge about the unseen cause as a way of explaining the observed fact. An example of this, consider an example where a person observes that there is smoke coming from a distant hill but cannot directly see the fire due to hill's view. To explain the presence of smoke, this person postulates the existence of fire on the hill even though it cannot be directly perceived. This is an example of inference. Unseen cause is postulated to explain the observed fact. Then anupalabdhi, non-apprehension, often referred to as non-apprehension or negative cognition, is another essential pramana in Indian philosophy, particularly in Nyaya and Vaisheshika. It involves the knowledge of the non-existence or absence of an object, event, or property. Types of anupalabdhi. Anupalabdhi is classified into 4 types in Nyaya philosophy. Non-apprehension due to absence. Atyanta anupalabdhi. This occurs when one recognizes the complete absence of an object or property that should be present. For example, recognizing the absence of sound in the room that should have been noisy. Then non-apprehension due to contradiction. This is the recognition of the presence of one thing in another due to mutual exclusivity. For example, recognizing the absence of wetness in fire. Then non-apprehension due to inference. Samsarga anupalabdhi. This is the recognition of the absence of one thing in another due to their inseparability. For example, recognizing the absence of coldness in ice. So, non-apprehension due to negation. Pradhana anupalabdhi. This occurs when one recognizes the non-existence of something explicitly negated, such as the non-existence of a jar in a table and explicitly stated that there is no jar. Significance. Implication is crucial for explaining facts or events that cannot be explained through other means of knowledge. It demonstrates the role of logical postulation in knowledge acquisition. Non-apprehension plays a vital role in knowledge, not acknowledging the absence or non-existence of objects or properties. It contributes to the understanding of negation and complements other pramanas. So application applied in various fields to postulate unseen causes to explain observed phenomena. It is commonly used in scientific and philosophical inquiry. It is used to negate the existence of certain properties or objects and is especially relevant in fields like philosophy and linguistics. So while we try to learn that, we could just have a conclusion. Arthapathy or implication and anupalabdhi is a non-apprehension are significant pramanas in Indian philosophy and epistemology. They provide structured and systematic approaches for explaining unobserved phenomena and recognizing the non-existence of objects or properties. Understanding these pramanas and their applications is essential. Then structure and kinds of anumana or inference. Then vyapti, invariable relation. Then fallacies of inference. Structure and kinds. First, anumana or inference. is one of the pramanas or means of knowledge in Indian philosophy. It involves drawing conclusions based on reasoning and evidence. Inference is a structured process consisting of several components. So, components of Anumana: Hetu, reason. Hetu is the reason or evidence used to draw an inference. It is the middle term that connects the subject and the predicate. So, Vyapti, invariable relation, is the invariable relation between the reason and the predicate. It is the crucial connection that ensures the validity of the inference. Then, Paksha or subject is the subject about which the inference is made. Then, Satya or predicate is the predicate, which is the inclusion which that to be inferred. Predicate is the Satya is the predicate, which is the conclusion of what is to be inferred. Then application is the application of the reason to the subject to establish the conclusion. Example of Anumana. Consider the classic example of inference: where there is smoke, there is fire. So, subject is the place where we observe smoke. The inference is drawn based on the invariable relation between smoke and fire. Then, invariable relation. So, invariable relation refers to the invariable relation between the reason and the predicate in the process of inference. It is the key to establishing the validity of an inference. Characteristics: it's universal, meaning it holds true in all cases of Hetu and Satya. And it is positive, meaning it affirms the presence of this when the Hetu is present. Vyapti is invariable, indicating that it does not change across different instances. An example of Vyapti, it is the example mentioned earlier. The invariable relation is that where there is smoke, there is fire. This relation is consistent across all cases where smoke is observed. Then invariable relation. Vyapti refers to the invariable relation between the reason and the predicate in the process of inference. It is the key to establishing the validity of an inference. And characteristics of Vyapti is a universal, meaning it holds true in all cases of the Hetu and Satya. It is positive, meaning it affirms the presence of the Satya when the Hetu is present. Vyapti is invariable, indicating that it does not change across different instances. Examples include, in the example mentioned earlier, the invariable relation is that where there is smoke, there is fire. This relation is consistent across all cases when smoke is observed. Then, fallacies of inference. Fallacies of inference are errors or mistakes that can occur in the process of making an inference. Nyaya philosophy identifies 5 common fallacies of inference. Fallacy of the consequent. This occurs when the reason is taken from the predicate, meaning making the inference circular and invalid. Then, Viruthas, fallacy of contradiction. This happens when the reason contradicts the self, referring the inference invalid. Then, fallacy of irrelevance. In this fallacy, the Hetu does not have a constant relation with the Satya or has more than one meaning. Then, fallacy of accidental prediction. This occurs when the Hetu and the Satya are similar in one respect but not in the respect relevant to the inference. Then, fallacy of unqualified generalization. A generalization is made without considering exceptions, making the inference unreliable. Importance of recognizing this. Recognizing fallacies of inference is crucial to maintain the validity and the reliability of the process of inference. Nyaya philosophy places great importance on avoiding the fallacies to ensure that reasoning is sound. Example: fallacy would be someone inferred that all men are immortal because Socrates is a man and Socrates is immortal. This is an example of fallacy as the reason is derived from the predicate. So, understanding the structure of Anumana, the importance of Vyapti in establishing valid inferences and the identification are essential in critical thinking and reasoning. These concepts are foundational in Indian philosophy and logic. Then data interpretation, sources, acquisition and classification of data. Data interpretation, sources, acquisition and classification of data. Introduction. Data interpretation is a critical skill in research, analysis and decision making across various fields. Understanding the sources, acquisition and classification of data is essential for processing and making meaningful inferences from information. Here we will delve into these aspects in detail. Sources of data. Primary sources. Primary data are collected directly from original sources. These sources can include surveys, interviews, observations, experiments, and fieldwork. Primary data are specific to the research or analysis at hand and are collected for a specific purpose. Then, secondary sources. Secondary data are already available and have been collected by someone else for a different purpose. These sources can include existing database, published reports, books, and articles. Secondary data are valuable for comparative analysis, historical research, and supplementing primary data. Acquisition of data, data collection methods. Data can be acquired through various methods depending on the nature of the research or analysis. Common data collection methods include surveys, questionnaires, interviews, observations, experiments, and content analysis. Researchers choose methods based on their research objectives and the type of data needed. And data sampling. Sampling involves selecting a subset of data from a larger population. It is a cost-effective way to gather data and is used when collecting data from an entire population is impractical. Sampling methods can be random, stratified, cluster, or convenience sampling. Then classification of data. Data can be classified into various categories based on different criteria. So based on nature, qualitative data. This data are non-numeric and describe qualities or characteristics. Examples include names, colors, and job titles. Then quantitative data. This data are numeric and can be measured. They include discrete data, whole numbers, and continuous data, fractions or decimals. Based on purpose. Primary data. Data collected directly from original sources for a scientific research purpose. Secondary data. Data collected by someone else for a different purpose and reused for research or analysis. Then based on level of measurement. Nominal data. These are categories or labels with no inherent order or ranking. Examples include gender or eye color. Then ordinal data. This data have a specific order or ranking but do not have consistent intervals between categories. Examples include customer satisfaction ratings. Interval data. This data have consistent intervals between values but there is no true 0 point. Examples include temperature in Celsius or Fahrenheit. Ratio data. This data have consistent intervals and a true 0 point, meaning the 0 represents the absence of the attribute being measured. Examples include age, weight, and income. Based on time. Cross-sectional data. Data collected at a single point in time. It provides a snapshot of a specific moment. Time series data. Data collected over a series of time intervals, allowing for the analysis of trends and changes over time. Then significance. Understanding the sources, acquisition, and classification of data is crucial for various fields, including scientific research, business analytics, social science, and public policy. It ensures that data is collected accurately, analyzed effectively, and used to make informed decisions and recommendations. Then conclusions. Data interpretation is a fundamental skill in research and analysis. The sources, acquisition, and classification of data are crucial aspects that form the foundation of data-driven decision-making and research. An in-depth understanding of these concepts is vital for students, researchers, and professionals in numerous fields, making them essential topics for examination. Then quantitative and qualitative data. Quantitative and qualitative data in detail. Quantitative data and qualitative data. Quantitative and qualitative data are two fundamental types of data used in research, analysis, and decision making across various disciplines. These data types differ in their nature, collection methods, and the kind of information they provide. Quantitative data are numeric and represent measurable quantities. They deal with objective and quantifiable attributes and are characterized by numerical values. This data type is used for quantitative research and statistical analysis. Characteristics of quantitative data. Quantitative data can be measured and expressed in numerical terms, allowing for precise analysis objectives. It is often used to study objective phenomena, making it suitable for scientific research. Statistical analysis. Quantitative data can be subjected to statistical tests such as mean, median, standard deviation, and regression analysis. Examples of quantitative data. A person's age is a numerical value, making it quantitative data. Temperature. Temperature readings are quantitative data expressed in degrees Celsius or Fahrenheit. Income is a measurable quantity. typically expressed in a currency unit like dollars or euros. Then qualitative data. Qualitative data are non-numeric and represent qualities, characteristics, or attributes. This data provide a deeper understanding of subjective experiences and are often used for exploratory research. And characteristics of quantitative data. Qualitative data describe the characteristics and attributes of a phenomenon in a narrative or contextual form. Subjective. It explores quantitative experiences, emotions, opinions, and behaviors. Then open-ended. Qualitative data are often collected through open-ended interviews, observations, or content analysis. Examples of qualitative data: interview transcripts, verbatim transcripts of interviews where responses are described in words rather than numbers. Then narratives, personal stories, anecdotes, and case studies that provide a rich description of experience. Then observations, detailed notes from ethnographic or observational research describes behavior and interaction. Then data collection methods. Quantitative data collection. Questionnaires and surveys are commonly used to gather numerical data from a large sample of respondents. Controlled experiments generate quantitative data by measuring specific variables under controlled conditions. Qualitative data collection. In-depth interviews. Open-ended interviews allow participants to express their experiences and perspectives in their own words. Focus groups. Group discussions are used to explore a particular topic or issue. Then participant observation. Researchers immerse themselves in the context they are studying, observing and documenting behaviors and interactions. Significance. Understanding the distinction between quantitative and qualitative data is essential for researchers and analysis. Both data types offer unique insights and are valuable in different research contexts. So quantitative data provide the ability to test hypotheses, make statistical inference, and measure relationship between variables. This makes it suitable for hypothesis-driven research and numerical analysis. So qualitative data, on the other hand, offer a deeper understanding of human experience, emotions, and behaviors. They are valuable for exploratory research, hypothesis generation, and the study of complex, context-rich phenomena.